Lesson 7-1, Solving Two-Step Equations. Alright, before we begin this lesson, I'm going to go over a couple examples that you can see here in the check skills you'll need. 1 through 5 listed below are one-step equations. Now we as 7th graders have already learned these. Number 1, 9 plus k equals 17. To solve an equation, you want the variable isolated or all by itself. I want my final answer to be k equals something. So, looking here, k is attached to the 9 with an addition sign. One way to solve for k, we can undo that addition by subtracting 9. So I'm going to subtract 9 from both sides. When I do that, k is left by itself. We have k equals 17 minus 9, which is 8. Alright, so that's a one-step equation. Review those if you need to prior to this lesson. Okay. So, moving on. In an example like this is called a two-step equation. This is what our lesson is about. Now, what you can see is there's a variable on one side of the equation. It's attached to a 2 or a coefficient by multiplication because they're close together. It's also attached to a constant. A constant is this number 1 because it doesn't have a variable with it. And it is attached to that one with addition. So there's two steps we're going to have to do to get x by itself. The first thing you want to do is eliminate constants, anything without a variable. So I'm going to subtract 1 to both sides. Doing this, I have 2x left on the left side. My equal sign, 5 minus 1 is 4. So I've eliminated one step. Now I need to do the second step. Now I'm eliminating, or I'm going to get rid of, the coefficient, the 2. Since x is being multiplied to 2, I can undo that by dividing by 2. And what you do to one side, you have to do to the other. So I'm going to divide 4 by 2. In doing this, the 2's cancel out. I'm left with just x. 4 divided by 2 is 2. Alright. We're going to talk about the algebra tiles in class. Okay. So let's do one more example. 3 times n minus 6 equals 15. I'm looking to solve and get n by itself. First step, get rid of your constants. In this case, negative 6 is a constant. It has no variable. You can look at this as negative 6 or subtract 6. Either way, the opposite operation would be adding 6 to both sides. In doing that, my negative 6 and positive 6 eliminate each other. I'm left with just 3n on this side of my equal sign. 15 plus 6, I get 21. That's the first step. Second step, I still have to get n by itself. I'm going to divide by 3, n equals 7. Now you can see this word right here that says check your answers. It's really important we learn how to do that. So once I have an answer for my variable, I can put this value back in my original equation for n. So let's do that. If I had 3 times, I'm putting a 7 in for n because that's what we just solved, minus 6, I should get 15. Well, 3 times 7 is 21, minus 6 does equal 15. So this solution works. If it didn't work, you would know you did something wrong in your solving for your variable. Alright, example 2, we're doing the same thing but we have a negative coefficient. So let's start looking at this one. We want x all by itself. Some people might think it's just one step. They might think they just have to get rid of the 5, but let me show you what happens when you do. Alright, so I'm looking at this 5. 5 is a constant. It doesn't have a variable. 5, some people don't know, do I add or do I subtract it? Well, you want to look on the outside of the 5. Is there a sign in front of it? Since there isn't, we assume that 5 is positive. To get rid of a positive 5, I'm going to subtract 5 to both sides of my equal sign. When I do that, my 5's are eliminated. Now, don't forget, you're not left with just x. If you look back in your equation, I'm left with a negative x equals negative 5. So in this example, when they mean negative coefficients, a coefficient is a number attached to a variable. In this case, there is a coefficient, but it's kind of hidden. When you see a negative sign, you want to assume there's a -1 in front of that x. So to get x all by itself, we're going to divide by that -1 to both sides. My final answer is just my x. -5 divided by a -1 is a +5. I'll do one more example. -a plus 6 equals 8. First, get rid of constants. The constant in this problem is just the 6. Look at the sign in front. I see a positive sign. I'm going to subtract 6 from both sides. Notice you're not subtracting from the a because, like apples and oranges, you can't add and subtract unlike terms. This is a constant because it doesn't have a variable. This term has the variable a. They're different families. We can't add or subtract them. The 6's cancel out. 8 minus 6 is 2. I'm left with -a. There's a negative coefficient by this negative right here, so I'm going to divide by a -1 to both sides. My final answer is a equals -2. Alright, third problem is just using these multi-step or two-step equations in a real-world problem. This one's been done for us. I'm going to go to the second example. Jacob bought 4 begonias in 6-inch pots and 19 ferns at a fundraiser. And a $19 fern, sorry. He spent a total of $63. Solve the equation 4p plus 19 equals 63 to find the price of each begonia. Let's look at how they got this equation. At the store, he bought 4 begonias in 6-inch pots. So we don't know the price of the begonias, so we're going to put P for price, but we know he bought 4 of them. He also bought a $19 fern, so I'm going to add that $19. That's going to give us a total of the $63 he spent. That's how you write a two-step equation. Now to solve for the price of the begonias, we want P all by itself. I'm going to subtract the constant that I see, which is 19. There's no variable attached. I have 4p left. I do 63 minus 19 and I get 44. Then p is attached to the 4 by multiplication, so I'm going to divide by 4, divide by 4. P, or the price of a begonia, with a dollar sign, is $11 for each begonia. When you put 11 back into the equation, 4 times 11 is $44, plus the $19 fern equals the $63 he spent. Alright, here's your lesson check problems. There are 5. These are two-step equations. Remember to first eliminate the constant. Second, eliminate the coefficients, which are numbers attached to variables. And then third, you can always check your answer. Good luck. Bring these answers to class on a sheet of paper in your notebook binders.